How does essential learning groups in mathematics affect engagement and academic performance of students in Year 6? Engagement within the classroom has long been a topic of discussion among significant educational bodies, mainly due to its noteworthy relationship with academic achievement and to optimal human development. Research suggests engagement has long been linked to academic performance. However, there is yet to be a universal consensus among researchers as to what comprises engagement. The aim of my research project is to determine the effectiveness essential learning groups in mathematics has on students' academic performance and engagement. The aim is to conclude whether or not this approach increases engagement and therefore decreases the likelihood of school dropout rates and negative behaviour towards school and education, particularly towards mathematics. An essential learning approach focuses on the questions of what do we want students to learn and how do we know if they have learnt it. It takes core syllabus outcomes and rearranges them to focus on what is essential for the student's learning. For example, the essential learning of this mathematics outcome would be expressed as students can read half and quarter hour time. Any further additions from the outcome would be reflected in the high and outstanding on the proficiency scale. The proficiency scale is created based on a need to know, good to know, and nice to know basis. 3 levels of proficiency are formed. Level 1, students have a basic limited understanding of the content and skills. Level 2, students have a sound understanding of the content and skills. And Level 3, students have a high to outstanding understanding of the content and skills. There has been quite a lot of positive research in regards to essential learning. Here you can see some researchers' positive stances. This topic is significant to my professional practice as it became evident during my teaching experience that I needed to work on strategies to engage students. Engagement is something I find difficult to constantly utilise and keep on top of in the classroom, especially when I myself am not enthusiastic about maths, and I was one of the students who dropped the subject in high school. Looking back, I wish I had not dropped the subject. I wish I was given opportunities and shown different strategies as a learner to perhaps increase my engagement with maths. Thus, I do think it is important to provide students with programs and strategies to help increase their engagement towards maths to hopefully lessen their chances of having negative views towards the subject, resulting in a downward spiral and hence dropping it altogether. Previous research conducted saw teacher support, motivation, and instruction as the main influences of engagement. Furthermore, these 3 influences were shown to increase engagement, which in turn proved to increase academic performance. Qualitative and quantitative studies were both conducted in the research, as well as a mixed methods approach. All studies further backed up the research and proved to confirm that engagement impacts on academic performance. Research collated on essential learning seemed to point towards a negative stance on ability groups. Some researchers point towards a decrease in self-esteem and disaffection impacting on low-achieving students who are placed in the low ability groups. However, a longitudinal case study of ability groupings and examination performance in mathematics concluded that the most negative effects of disengagement towards maths wasn't from ability groupings, but rather appear when teachers use traditional teacher-directed whole-class learning. Also, in response to this, use of flexibility is advised when it comes to groupings, which would see a positive impact on those low-achieving students as they are not strictly bound to the low ability groups. Focusing on a student's zone of proximal development is also a good way to counteract the negative impacts groups may have on students. Further research conducted on essential learning groups proved to highlight a gap in the literature. Through extensive searching, only a diminutive number of articles were found, highlighting a need for further research. There are also limitations when researching this topic, as most of the articles are aged and outdated, warranting future study, so that terms, practices, and knowledge are relevant to the classroom today. Also, most articles found were typically American, with only one coming from Australia. This makes it difficult to determine whether the above influences would see the same effect in Australian schools on classroom engagement, thus promoting a need for future studies to be conducted in Australia so that there is relevance in the literature. Lastly, and most importantly, while the research mentioned the importance of engagement and what influences it in a primary school setting, there was no research conducted on what strategies teachers can use to engage all students in the classroom, which is an important factor in encouraging equity and student success. While this approach is based around the pragmatic paradigm, the transformative paradigm is also present due to this study incorporating change, as it proposes a new strategy to be utilised in the classroom which should see students' engagement and academic performance levels increase, and therefore, in the long run, potentially decreasing dropout rates. This study assures anonymity as all participants involved will not have their names or any personal information published. Pseudonyms will be used instead. All data to be utilised was first checked and clarified with my associate teacher and school principal. This study is identified as minimum risk. A minimum risk checklist was completed to ensure this. The study was conducted on my internship in weeks 8 and 9, focusing on the use of essential learning groups in mathematics in the Stage 3 Year 6 year group. In week 8, the students were taught mathematics as a whole class, undergoing whole class learning without using essential learning groups. They also completed a pre-test for the following week 9 module. In week 9, the students were put into essential learning groups based on their pre-test results and taught content specifically to their level. Observational checklists were completed in both week 8 and 9 of the study. At the end of week 9, students completed their reflection of the past 2 weeks as well as their post-test. My findings from the data collected during my action research study proved to show that essential learning groups have impacted positively on student engagement as well as student academic performance. The table shows a quantitative approach through using statistical data of students' pre- and post-test scores before and after undergoing essential learning in week 9. Using Cohen's d, I was able to prove that a moderate to large change had taken place on students' academic performance in regards to this module. Qualitative data was also collected. I collated the data from my observation checklist in week 8 and 9 and noticed a difference in students' engagement. In week 9, it was more evident in the groups that more students were actively participating in group activities and answering questions. Less were noted down as off-task. This could be due to the learning being targeted at the students' actual ability. Overall, the checklist proved that students were more engaged during essential learning groups than whole class learning. This was further backed up by the students' reflection. The graph shows the students' own feelings and attitudes towards essential learning groups as well as a whole class learning approach. The findings were taken and assessed as quantitative data, which showed that students felt more engaged during essential learning groups. 69% of students either agreed or strongly agreed to paying more attention in maths groups, while 85% of students either agreed or strongly agreed to enjoying maths more since being in groups, while only 10% of students preferred whole class learning as opposed to maths groups. 73% of students find they actually learn more when they are in their maths groups. Thus, through my findings, I can conclude that essential learning groups have proved to increase students' engagement in mathematics and therefore enhance academic performance, which can also be seen through the post-test scores. As a result of this action research, my future teaching practice will look at considering essential learning in mathematics. A future change I will definitely be making is to ensure flexibility within all ability groups, as it was never something I had thought to consider before. There was just students who were bad at maths and those that weren't. Now I know that students can be high achievers in some concepts, however struggle in others. Implementing specific learning pathways is definitely another factor I will be incorporating into my future teaching, as well as giving students the responsibility to complete their own I can statements, which saw a newfound ownership in their learning. They felt more in control and engaged to learn as they were taking the responsibility. However, this is not something I can implement in a classroom without all staff in the stage group getting on board, as it is applied across the whole stage year level. This could see drastic changes in future schools, as essential learning could become part of a whole school professional learning approach. Thus, this study would influence teachers, principals, and students. Through undergoing this study, I saw a small transformative approach take place within the students' own attitudes towards mathematics, as well as witnessing their increasing academic results. As previous research has identified, engagement impacts on student achievement, and that is what my research study has proven. When students seem to be more engaged through a strategy utilised such as essential learning, their academic results increase, which has definitely been the case here.